All right, so today we're going to be doing a review for the final exam. Some information about that has already been posted to Piazza. This information, it will be held on Monday the 13th, so less than a week from today. That is the official day of the final. I think that there's some block of 2 hours that's been scheduled, but of course it'll be like the midterm where you have up to 24 hours to do it. It'll be open and available on Canvas starting 1 second past midnight. So if you're a morning person, you want to do it early, great, go ahead. If you want to, I don't recommend it, but if you want to do it at the evening, that's fine too. You can, you have 24 hours to complete it. It will not take you 24 hours. It is designed for, 2-hour block. I think I announced it on the main section, but I don't know if I announced it here or not, but it's not that big of a deal. I already told people what one exercise at least that'll be on the final. It's Fizz Buzz, all right? So look that up and you can properly prepare. Anyway, it's 100 points or about 7.69% of your grade. It's cumulative in that it will rely on all the skills that you've developed up to this point. Starter code may be provided. No collaboration or outside help is allowed. You can post to Piazza and we will be available for questions, clarification questions. Don't post code. And we may not be able to give the level of help that we would give on a hack or a lab or something like that. Remember that there is a final exam bonus of up to 15 points based on the response rate for the course evaluation. Don't just fill it out to fill it out, though, please. I do take them seriously, and I do make changes to courses based on that feedback. So make sure that you're making a thoughtful response to those end-of-course evaluations. Because they are anonymous, I'm only able to give points based on the response rate. So the number of people who fill it out divided by the number of people who take the final times, it's actually supposed to be 15 points right there. It is up here. Which turns out to be a little bit more than 1% of your final grade. So encourage your peers to fill it out. You don't need to fill out the one associated with the lab if you don't want to. And without any prompting, as of the post that I made yesterday, 4 out of 21 have filled it out. I expect about 19 will sit the final. Okay. Questions on the final format? No? Remember, we are online, so if you have any questions, post to Piazza or post to YouTube, and I'll see them either one. All right, then, let's go ahead and start with a final from a few years ago. This is the final from this course 3 years ago, and it has the same exercise in C, and then repeats in C and Java. So since I did this exact same exercise yesterday in the main section, but I did it for the C version, so we can do that. We're probably not going to be able to get through both of them here. But that video is available if you want to. Go ahead and watch the video from yesterday if you want to see the C version. In the interest of time, we'll go ahead and start out with the Java version here. So let's understand what it is, first of all. Pokemon is a game where you battle these two Pokemon together, and each Pokemon has a type of attack or defense. For example, ice, grass, fire, etc. When an attack of type A is made against an attack of type B, it does either no damage, it's not effective at all, it's 50% is effective, 100% normal, or 200% is super effective. And this is all established in this grid here. We won't go over the details here, but when normal fights normal, then the blank here is just normal. When electric fights ground, I don't know why, but it is not effective at all, right? 0. Something that's really effective here is when grass fights rock, I assume that is, then it's doubly effective for some reason. Grass fighting rock, okay. Anyway, you've got this grid here, and you've been given these as data files, right? The first one is Pokemon types.dat, and you can see what it looks like here, that it is the type of attack times and then the second one is the type of defense, and then the multiplier right here. And we've also been given information on all these Pokemon in a CSV file. There are 151 of them. Right? The format here is that they have an ID, they have a name, and they have a type. So the purpose of this program is to process both of these files and then take as command line arguments a Pokemon that attacks another Pokemon. So Jinx here will attack Flareon, and Jinx is of type Ice, and when it attacks Flareon of type Fire, it does half as much damage. So Ice is half as effective. Right? Are we good on the setup? Okay. So for the Java version, I didn't give any starter code at all. For the C version, I gave a bunch of starter code that would help you, say, process these files. Of course, in an exam, you're able to use whatever you've developed in your hacks, in your labs, etc. For example, what's one thing that you would probably want to use, or at least refer back to? A way to process these files line by line, right? Or read them all up line by line, and then split them out into tokens, okay? So I've come over here. Let's come over here and let's start. First of all, Pokemon has an ID, a name, and a type. What is that screaming out to you? If it was C, make a structure. If it's Java, then make a class. And I've already started on the class here. What is in the class? Private int ID, private string name, and private string type. Now, there are only 18 types here, normal through, I think this is fairy. So you could put that into an enumerated type if you want to. I'm just going to go ahead and keep it and model it as a string here instead. Okay? Now, I'm going to want a constructor, getters, setters, maybe, etc., etc. Do I start typing? Nope. What do I do? Source. Generate a constructor using fields, all of them. Done. Source. Generate getters using, just select all the getters. Done. My class is done. Right. Now let's go ahead and process that file. So public static void main string args. There we go. And I'm going to want how many command line arguments because this is Java. Oops. Let's get rid of this. How many command line arguments? There's the class, and then the first Pokemon, and then the second Pokemon. Right? So I'm going to expect how many command line arguments because it's Java? Just 2. In C, it would be what? 3 because of the executable file name. So if args.length is not equal to 2, then system.error.println usage provide to or Pokemon 1, Pokemon 2. There we go. All right, and we'll exit to system.exit with an error code, say. Okay. Otherwise, we've got 2 Pokemon. Their names. I'll go ahead and put those into strings that are actually, Pokemon or attacking Pokemon. Attacking Pokemon is equal to args of 0. Do I need to do anything fancy like create a brand new string, allocate memory, etc., etc.? Not with Java, right? Defending Pokemon, args sub 1. Right? So I've got the attacking Pokemon and the defending Pokemon. Right? What should I do now? They're all in the file, CSV. Right? So I should probably be processing that file. Right? All right, so 1, open the file. 2, process line by line, create Pokemon. 3, close the file. Right? So that seems like a complex operation that results in this list of Pokemon. All right, so what is that screaming out to you? Complex chunk of code, what do you do with it? Put it into a method. So let's go ahead and create a public static list of Pokemon method. So get Pokemon from file, right? And then we'll provide a file name to this method. Right? And now we don't have to worry about this 1, 2, 3 step process here. Instead, I just, assuming that it's already done here, Pokemon Pokemon or men, whatever is. There was some I made the joke yesterday that what's the plural of Pokemon? What is it? I think it's just Pokemon. Pokemons? I don't know. Anyway, whatever. And what is that Pokemon file? Well, in this case, I've stored it in data pokemon.csv. So data/pokemon.csv. There we go. Okay. And, oh, well, okay, we'll go ahead and import list. Why did I do lists? What alternatively could I have done? Pokemon array? Icky. Why icky? It's not as nice, right? You can't automatically add stuff. You can't search through it. You can't, easily, I should say, et cetera, et cetera. So let's just go ahead and keep it as a list, right? Why use a broken down car when you've got a Cadillac over here, right? Brand new Cadillac. All right, so I'll go ahead and create a list of Pokemon. And I'll call it result here is equal to new. Can I do it like this? A new list?
Yes.
Careful. Is that how we've done it before? Array list, there we go. Right? Why? Because one is the interface and one is the implementation. We'll talk about that in Computer Science 2 next semester. Right? Okay. I need to import this. And I need to return the result. Now at least everything will compile, but of course I'm not reading any Pokemon yet. So that 1, 2, 3, I'm going to cut and paste it up here. Help me out. Java, how do I open a file? F is equal to new file, a scanner. And the file I want to open is file name, right? And then create a new scanner. S is equal to new scanner based on that file. Make sure that you import, and unfortunately it's going to gripe about this because that is a checked exception. A checked exception is something that you are forced to try and catch. So how are we going to deal with this? Try, catch, and release by rethrowing it. So throw new runtime exception, which is an unchecked exception, E. Okay. I'll just go ahead and do everything inside the try here. All right. So help me out. What should I do? Well, it has a token or a line to process here, right? While s dot has next line, right? I can go ahead and create a line, string line is equal to s dot next line. Now, one problem with this, potentially, that you've already seen with your project is, are there going to be any Pokemon on those lines? Blah, 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 whatever. Is that a Pokemon? No. So, in the handout, I say that there are only 151 Pokemon. Right? And like in the project, the first line tells you exactly how many lines to read. I don't have that right here. I could have done it like this. Read only the next 151 lines, right? You will get yourself into trouble if you just blindly continue. So what's an alternative here to make sure that I don't do that? A for loop. For int I is equal to 0, I is less than 151, I plus plus, right? And this is screaming out to me, magic number. What the hell is that? If you want to be good about it, you can go ahead. Oops, I don't want that. I want public static final int num Pokemon 151. And then I can use that all over the place if I really want to. It's not going to be that big of a deal in Java because once I've used 151 here, and I'm using a list, I don't need to ever use that again. List.size will tell me that there are 151 records in there. Okay? All right, but otherwise, get the line. Now what do I do with the line? Oops. Split it. Good. So, string tokens is equal to line.split. How are we going to split it for the CSV file? Comma. Right. Now that's going to be 3 tokens. The ID, the name, and the type. All we need to do now is create a new Pokemon. Pokemon P is equal to new Pokemon of tokens sub 0, token sub 1, okay, token sub 2. If you want to, you can put these two into another variable called name and type if you want to. But what's the problem here with this first token? Is that a string? Nope, it's an ID. Token sub 0 is a string. So what do I do to convert a string to an integer? Integer.parse int tokens there. Now that I've got my Pokemon, what do I do with it? Add it to the result. There we go. Result.add p. Done. Close the file. Oh, okay. What do? I don't close the file here in Java. Instead, I close the scanner. It's going to complain about that. Why? Because its scope is within that try loop. Okay, fine. I'll move you up here after the for loop. Okay? Now it's all happy. What's another alternative way that I could have done all of this? A try with resources block. And now this close is not necessary at all. Because I have created it and I've initialized it in this try statement, it'll automatically be closed at the end of this try catch instead of in a finally. It would have been better to do it in a finally statement anyway. But this syntax relieves me of the need to do any of it at all. Okay. Let's go ahead and make sure that this actually works, at least a little bit, right? System.out.println. This is just a sanity check here, right? Does it actually work? Oops, okay, fine. I need to provide 2 command line arguments. Help me, give me 2 Pokemon. M-E-W? Bulbasaur. I assume that that's how you spell it, but we'll find out. All right, there we go. Oh, I've got a lot of Pokemon, but there are these random numbers. What are they? That's memory location. Why? Because I didn't have a toString method up here. Okay? So let's create a toString method. Type. Nope. Source, generate, at least as a starter here, generate toString. There we go. And I'm going to go ahead and change it. I don't care about the ID. I do want the name, though, and then the type inside of this parenthesis. Why? Because that's what it looks like in the handout. Remember? It looks like this. Jinx, and then parenthesis ice. So when I do that, I get all these human-readable things now. Bulbasaur grass, Bulbasaur, I think I spelled it right, great. I don't like that. I like putting a space there. All right? Nearly halfway there already, right? So I've loaded up the Pokemon, and I am confident that I loaded them all up. Of course, I could look at the end here and see what should be the last one. I'm not sure. What's Pokemon 151? Anybody know? Mew? Okay, there we go. Hopefully you remembered it from this file, or you've committed all 151 of them to memory. All right. So next thing I need to do is load up these type attacks. In other words, I need to load up this chart right here. Okay. Now, the way that I did this in C yesterday is I created a 2-dimensional array of doubles. And then I associated each one of these strings with a particular index. So that I would say that normal is associated with index 5. So that I would go with index 5, and then fairy is associated with index 8. Right? And so I would use those indices to look up the value in that big grid. I did what the picture looks like here. In Java, let's think of an alternative. Think back to your recursion hack, right? Where you had to do n choose k, and then you had to cache the result, where n and k, given those 2 elements, we combine them together into a pair, and then we map that to something else. Let's do the same thing here. So I would bring in the pair class that I gave you already for hack 12, I think it was. Pair of string, Pokemon, or type, I guess it is, right? String to string, right? So this is the type pair, right? And then what we would want to do is we would want to map that mapped a pair of strings to a double. Why a double? Because it's going to be 0.5, 1, 2, or I guess 0 is also an option, right? So a map of pairs. All right, let's go ahead and start with the map. M is equal to, okay, M, there we go. Import that, or import the map first. Come on. Then import the pair. Originally, that I would just copy and paste the class that I gave you, right? Yeah, go ahead.
So is the pair something you created, or is it part of the language?
That's not part of the language. I'd love it if it was part of the language. That's called more generally, that's called a tuple, and it's built into, say, Python. That's one thing. I don't really like Python all that much, but it's one thing I do like about it, is that you have these native tuples. If you want to pair a singleton, if you want a pair, if you want a triple, a quadruple, it's built into the language by just using the parentheses. This, you have to create a class called pair, or a class called triple, or a class called etc. There are recent additions to make it look like you can do something like that. I believe that there is a tuple class. S. And where is it? Nope. Maybe not. I thought that there was a tuple class introduced in more recent Java, but nope. Not, at least not in this one. Whatever version I'm using 12, so yeah. Yeah.
The two strings, like one of them will automatically become the key and one of them will become the value.
Actually, the entire pair is now the key, and this is the value. But the combination, the ordered combination of the two, because ice attacks fire is not the same thing as fire attacks ice, right? All right. Of course, you could do this with just a big giant grid if you want to, a two-dimensional array of doubles. I don't want to do that when I've got this nice, data structure to do it for me. Okay. And I'll call this something better. Type multipliers is equal to new hash map, and I don't need to repeat the typing over here. All right, import that. Now I need to, again, 1, load the file, 2, build all the types, 2, double maps, pairs, right? And 3, close the file. Okay, what should I do? Put that into a method. And I'll put it up here. Public, static. We will return a map of pairs. Get multipliers. There we go. And string file name. Loaded up from that particular file. Oops. Return type multipliers. There we go. And bring this up. All right. Now, once I've done this, of course, I can use it down here. And that file is in data / what did I call it? Pokemon types.dat. That is not a CSV file, is it? Right? Well, how are the tokens separated now? Spaces. So we'll use the same technique. It's just that we'll split instead of on commas, we'll split on spaces. Okay? So let's go ahead and complete this. Open the file, scanner, right? Lots of copy pasta here, in fact. We can go ahead and do that. But we are going to get ourselves into trouble if we just blindly do that. Num Pokemon. I could use that, but how many lines am I going to read? I could look into the types over here. How many? I told you that there were, I think, 18 types. Is that right? If you count the number of types over here. 18. So how many combinations are there? How big is this grid? 18 times 18, which is 324. Right, so here there are no trailing lines, but we can go ahead and hard code this to 324. That seems like a magic number to me. Maybe put 18 into a variable and then do whatever that variable is times that variable, because that's how many records you should do. I'll let that as an exercise for yourself. I'm not going to split on commas. I'm going to split on spaces. I'm not going to create Pokemon. Instead, I've got tokens sub 0 is the type 1. I will put these in the variables here to identify them. Type A, attack, and then string type D for defense, tokens of 1, and double multiplier is equal to tokens of 2. Except that is not that's a string, that is not a double. How do I convert a string to a double? Double dot parse double tokens sub 2. There we go. And I don't add it to a list anymore. And what I need to do is I need to add it to this map. I want to take type A, type B, and associate them together. So let's do that one separate line here. Pair.make, type A, type D. You use that class in your recursion, right? In your recursion hack. Okay, right? I gave it to you for free because this is really nice, right? You can take two things, it doesn't matter what they are, and put them together, right? It's a pair of strings, though. P. I haven't used P here, but pair, right? There we go. And then I can take my map and map that pair, dot put P, and then the multiplier. I don't add things to a map, I put them there. This is the key, this is the value. The pair together as one object, paired together, is the key that goes over to the multiplier. That looks good. Format it up. Right. Now let's use it. So I've got my type multiplier here. What do I do now? I need to find the Pokemon with name attacking Pokemon to get its type. Okay. One option is to use a linear search, right? Just walk through this list of Pokemon. That's not, I'm looking for, what did we say? You said Mew, right? I'll start at the top. That's not it. 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 Dot, 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 until you get down to the bottom, right? An alternative is to use binary search. So let's get some more practice by using binary search here, okay? Binary search requires what about this list, though? That it needs to be sorted. So, collections.sort Pokemon. What's the problem there? Yeah, we need a comparator. It doesn't know this is your class. I don't know how to sort this. You sort it by ID, sort it by name, sort it by type, some combination of the three, etc. So let's make a comparator for Pokemon that does it by, how are we going to search for it? By name. Okay. What's an alternative, by the way? What if I had a map? Instead of storing this as a map, what if I had a map? Instead of storing this as a list, what if I had a map of Pokemon name to object? In other words, what if it would look like this? String, which is the name of the Pokemon, and then it mapped to the Pokemon object itself. Then I could look that up really easily. But let's hold that off to the SQL. Right? We'll do that if you want to. It's going to be pretty easy. But I do want to get some more practice with comparators and binary search, because you are maybe going to need that for your project. Yeah?
So if we're dealing with primitive types, we can use the sort method without creating
with the built-in types. It will even work with strings. So yes. But of course, it still has to be a list. Can't be a set because a set is unordered. it can be an array, but then you need to go, instead of collections.sort, you need to go arrays.sort. Right? And then the built-in primitive types, you can sort an array of those things. So let's create a comparator here. What's the easiest way to create a comparator? Public, static, final, comparator for Pokemon, right? By name is equal to, I could create a new comparator, right? And then inline define it and do a bunch of stuff, or compare tor dot, isn't it comparing? Yeah, I need to start with a class, and then it builds the comparator for me. Comparing what? Pokemon get name, right? Remember that this is the method selection operator. This is the class. Which method should I use to compare that get name, right? And that's only possible because I already generated the getter down here. Done. I didn't have to write much code there at all, did I? Very, very convenient. So, Pokemon by name. Once I've sorted it, I can find the Pokemon with the attacking Pokemon. So Pokemon attacking is equal to Pokemon dot, or no, sorry, collections dot binary search. And the two arguments here are going to be what? The same as before, by name. There we go. What do you complain about? Binary search. List comparator. Oh, comparator, right? Yeah, I did it. It is. It's right there, right? What are you complaining about? Binary search. I have to read really close here. My eyes are not great. Arguments, list of Pokemon comparator.
Should the second one be the object, and then the comparator after that? Object comparator, or list key?
Up there. The key. That's what you were saying, but then you used the keyword there being key, right? I need a key to search by here. So let's go ahead and create a key, right? Pokemon attacking key, and I'll just go ahead and create a new Pokemon. It doesn't matter what the ID is, 0. The name of the attacking Pokemon would be up here. And then finally the type, I don't know, so I'll just go ahead and pass in null. Right? And I will need a defending key. There we go. And that's the defending Pokemon's name. Okay. I don't like those names anymore, so let's go ahead and refactor those. Refactor, rename, name. And you'll note here that it's automatically changed down here. Awesome, right? Name and name, done. By name, which one is the key first? I forget. List, then then key, then comparator. Thank you. Attacking key. There, by name. Maybe it's not the order. From in, oh, fine. Int attacking index. I keep forgetting how to do this. Switching languages back and forth, whatever. Defending index. All right. Besides, this is not how I would do it anyway. I would do it with the map that I mentioned before that we'll do here in a second. It's a better solution anyway. Defending key would be here. Let's just make sure that this works so that I get the Pokemon attacking is equal to Pokemon.get attacking index. Gotta spell it right though. There we go. And then defending, there we go. So now let's go ahead and make a sanity check here and print them out. System.out.println. What is the expectation here? Pokemon attacks blah, a Pokemon does blah damage. So Pokemon attacks, Pokemon does %F damage. And for that, I will need, oh, let's go ahead and format this, print F. And the first Pokemon is attacking, defending, and then multiplier, which I have yet to do. Double mult is equal to 0 for now. Right? Oops, index negative 11. I must have spelled Bulbasaur wrong. You're going to have to help me here. What is the correct spelling of these things? MEW, BUL, BASUR, SUAR, AUR. All right, there we go. Apply that, run that. Uh-oh. Okay, well, that's understandable. Percent. Conversion, okay. 2F, there we go. That's why. There. Mew attacks Bulbasaur. Is it Psychic and Grass? Good? Okay, I'm convinced that it works so far. But now I actually need to look up this multiplier. How do I do that? The map that I created. Type multipliers. Dot get. And then I need a pair of Pokemon. Dot make. The attacking Pokemon, or attacking, but it's not Pokemon, it is string, representing the type, right? So attacking dot get type, and then defending dot get type. There. So I make a new pair. If you want to, you can go ahead and do that on one line. Call that the key. So pair of string, pair key is equal to this. And then you can use the pair key as your key. So what should it be? Psychic attacks grass. Does anybody know? It says 1. Psychic attacks green, I assume, is grass. So 1. All right. Give me another one that you know of, that you know the correct answer to. Nobody wants to admit to knowing all this stuff. EV, and give me somebody else. What is it? Charizard. What should that be? Normal, attacks fire, 1. Okay. Yeah.
For maps, is there like a get key function or get value function?
There is a get, like a set of keys. So with a map, I've got this map here. Let's just do a simple map here, that string to integers, right? Foo is equal to new hash map. Right? And then fill up your map or whatever you're going to do. For, give myself some more room here. If you want to iterate over all the keys, for each key, which is going to be a string, s, in the collection foo.getKey, or .key set, this will iterate over each one of these keys. Now, given the key, you can always get the value by going get. But if you wanted to iterate over the values, it would be foo.values. And then there, it wouldn't be strings, it would be integers. That would not get you the keys. It's not a bijection. It is a one-way. Yeah, if you want a bijective map, then you're shopping for a different library entirely. A bijection would be where you can go one way and then back, right? And that would not necessarily, I mean, that has its uses, but you have to be careful there because it's always a bijection is always a one-to-one thing, right? With a map, you can, just like a function, you can have one value that maps to one thing, but then you can have a different value that maps to the same thing, right? And that's why it's a map. It's an actual function. You can't have one key mapping to two things, just like you can't have a function mapping to two things. What would that look like in the Euclidean plane? Here's your xy axis. vertical line, it fails the vertical line test exactly. Like a circle is the classic example. You can't have a function, x, mapping to a positive and a negative at the same time. That's why a circle is not a function. Okay. What would it look like if I were to do this a little bit differently? In fact, let's go ahead and get rid of all this stuff, and let's build an even better map. So I've got all the Pokemon in a list. I've got all the multipliers of a string to string. What would be even simpler? What if we had a map of Pokemon to Pokemon of a pair of them mapping to a multiplier, a double? Then what would our final line look like? I'll just call this M is equal to new hash map. There we go. Or I guess string to string. I still need that, wouldn't I? I would still need the Pokemon, but then I could use those Pokemon to look up this double. How might I build this map? Instead of just getting one pair, get all possible combinations. 151 times 151, right? Do we want to do that, or do we want to do something else? I'll let you decide. We've done everything with respect to the Java version here already. This, or say advent of code, or do this again in C. Although again, that's available in yesterday's lecture. What do you want to do? Advent of code? Okay. I haven't even started yet here. Has anybody started? No? Okay. We'll do this, but then we'll do it in C so that we get at least another language here. Okay. I do have my CS50 IDE over here. CD at. Okay, fine. IDE. We'll let that load. Hopefully it does. AWS outages. Great. We might be going to the command line here today. Anyway, let's read while that's hopefully loading. I think I read this before, but I've forgotten it. You're given this series of numbers here. Don't worry about the story. You can read the story if you're really interested. But you need to count the number of times it increases or decreases. So for example, if it goes from 199 to 200, it increased. I think that this is a depth or something. And then it goes from 200 to 208, it increased again. 208 to 210, it increased again. But then it goes back down to 200, which is a decrease. You need to calculate how many times it increased. Right? And this is all given to you in a file. So let me go ahead and get my puzzle to see what it looks like. It's quite large, right? Wow. I don't know how many lines there are, but whatever, right? You could put this into an Excel file really easy, and then just have a macro on the right-hand side, pull it down, count the number of times it increases. But we're going to do this the hard way, and we're going to write some C program to do this. Okay? Go ahead and get rid of this. Are you back? Yay, you're back. Advent of code, CD, or let's make a new directory for 2021. All right. And I will touch day01.c and touch day01.input, or input.txt. Expand this out so that we can work with these files. I will take my input here, paste it here. Excellent. The line counter tells me that there are 2,000 numbers here. All right. So step one, include stdlib.h, include stdio.h. Why IO? Because I'm going to be doing file IO. I could go ahead and come over here and format this so that it's already in a, I could add commas to every single end line and then put it into an array, and I wouldn't even have to do any file IO, right? But this is practice, so let's do that. Int main int arg c char arg v. Okay. So let's open and process the file of integers, ... Help me out. Okay. File f is equal to fopen. Which file are you going to open? day01 input.txt. And you're going to open it up for the purposes of reading. Right? Check that it was successful. Right? If f is equal to null, then I have to quit. Exit 1 with an error code. Error message as well. Right? I'll let you do that as a take-home exercise. Yeah.
Can you do that error handling for the Sparrow project and the final project?
Basic error handling, yeah. But we will not give you malformed input files.
Oh, okay.
If we tell you that there are 7 tokens, there are always going to be 7 tokens. That first line does not lie,
Okay.
right? From that perspective, it's all going to be valid data.
Okay, so we don't check if it's in
No.
but we check if it's a null and
Yeah, I mean, we're not going to throw that at you either because I don't want to automate that garbage. But you do need to take command line arguments because we do give you different file names. There's 4 different test cases. I need somewhere to store them, right? And these are all integers, so an integer array would be a good place to store that. Int star malloc. Now I could, of course, create this is C, so I could create a static array of size 2000. 2000 is not that big, right? 2000, that's going to be what? Times 4, that's 8,000 bytes, so that's less than 8K. That's not going to break the bank. That's not going to risk a stack overflow, but it's much better to use dynamic arrays. Okay, it's way safer. How many do you want? Size of int times 2000. 2000. Probably want to put that into a variable because I'm probably going to be using that all over the place. Okay. So n. All right. And then read line by line. How am I going to read line by line from a file? Do you remember or do you forget? Right. Good. And because I know exactly how many I'm going to read, I can go into a regular old for loop instead. For int I equals 0, I is less than n, I plus plus. I will go ahead and get the next line. Of course, I need to store that line in a buffer. So I need a char buffer. Any line is going to be, 100 is certainly big enough for any of those lines, right? It doesn't look like it goes more than 10,000. So all I would need is 5 plus the null, plus the end line character because it's a line, plus the null terminating character. So I could get away with 7 here, but why risk it? 100 is good enough. Read it into the buffer. At most 100 minus 1 for the null terminating characters, and read it from f. Okay? Now I need to put into array the ith element here being whatever's stored in the buffer. Buffer. Is that going to work though? Buffer is a string. Array is an array of integers. How do I convert a string to an integer? A to I. And by the way, for your project, how do you go the other way around? How do you convert an integer to a string so that you can get the first character to do Benford analysis?
You just plus like empty quotations plus the integer, like concatenate.
Say that again?
Like you can take empty quotations plus the integer and you can just concatenate it or that.
That's not going to work. That'll do something, but it'll probably be dealt with like by getting the ASCII text table value, which I think 0 is 48, which you don't want that. You could always like subtract 48 and get it back to 0, and 1 is 49, so subtracting 48 from that will give you 1, et cetera, et cetera. But how do you convert an integer into a string? How do you print it to the standard output? Printf. So you can use sprintf to print it to a string and then just take the first character. Right? Super easy. Okay. So That's sprintf, right? Sprintf. Yeah.
Is there like a two-string thing?
Nope. I mean, that's basically what sprintf does. Whatever you want to format, you can use a printf style formatting to print it to a string, and then you can do whatever you want with it now that it's a string.
Alright.
All right, so I've got all of my numbers at this point. I'll close it for close the array. Now I just need to go through and count the number of times that it increases. This is the advent of code over here, right? So I'm going to start at the first one and look at the next one. And if it's greater than the current one, then I will increment an increased counter here, okay? So let's come back over here. Int num increases, I guess. Is that a good idea? No. What value is stored in num increases right now? Who knows? Maybe dead beef, maybe garbage. 0. All right? 4. Int I equals 0. I is less than n. Maybe that's wrong. We'll come back to it here in a second. Oops, that's certainly wrong. I plus plus. All right. There we go. If array sub I plus is strictly less than, it didn't say anything about equals, right? Did it? Maybe we're not going to have that, but it doesn't have, it does, no. Quickly depth of increases, strictly increases then, I guess. Right? What happens when it's equal? It didn't say, so I'm not going to bother with it. Array sub I plus 1. Right? So when the next one is strictly greater than the ith one, then I will increment my counter. Num increases plus plus. And then at the end, I will print it out. Printf number of increases, %d, and the line, num increases. All right. Careful. What happens when I get down to the very end? I go 104, 15, and then I look off the deep end here. Okay. There's the gotcha of day 1. I shouldn't go all the way up down to the last one. What should I do? I should stop short. Right? Let's see if I've got any syntax errors here. Oops. Huh. Don't close the array. What do I close? The file. Technically, if you want to, you can, at the end of the day, you can go ahead and clean up after yourself and free that array that you created. This is nice, but it's not necessary. It is not necessary even for grading purposes. If you create something in the in a function, if main owns a chunk of memory, you don't necessarily have to clean it up at the end of main. Okay, in these types of programs, because once main dies and the program dies, all of the memory gets cleaned up with it. So strictly speaking, this is not absolutely necessary. If this were a long-running program, like a graphical user interface program or something like that, you better be sure to clean this stuff up after you're done using it. All right. If it gets a few arguments. Oh, nobody caught that.
Does it take n as well?
There we go. Where?
Does it take like n?
No, the complaint was that I had a semicolon here instead of a comma. Okay, there we go. A dot out. Ooh. 1,754 increases. Okay. How could I, now, instead of blindly entering this in as my answer, what could I do? I could test it on the one that they gave me. And because I wrote this a little bit modularly, I could go ahead and save that, come over here, change 10 to 10, and I think the answer was 7. 7, okay. I'm 50% sure that this works. Come back over here, undo that, back to 2000. What was it again? 1,754. Come back over here. Of course, you could always go through it by hand and and count them up. I'm not going to do that. But that is kind of suspicious that there's 1,754 out of 2,000. But I guess it did look like it was all ascending almost, right? So let's see if I get my star. Yay, I got it. I got 1 gold star. We have 20 minutes left. So you want to try part 2? It's always a little bit harder. All right. I haven't read this at all here, so you're going to have to help me. Considering every single measurement isn't as useful as you expected, there are just too much noise in the data. Instead, consider sums of 3 measurements sliding window. Again, considering the above example. So A, B, A, B. Okay, so we've got these 3 measurements here now. Start by comparing the first and second 3 measurement windows. So I assume that that's this first one here. Yeah, 199 through 208. Their sum is 607. We can increase the size here. Their sum is 607. The second window is marked B. Oh, no, it starts at the second one. So it'd be 201. It's not like 3333. It is these 3, then these 3, then these 3, etc. All right. Its sum is 618. The sum of the measurements in the second window is larger than the sum of the first, so this comparison is an increase. So 608 increase, no change. Oh, now we have no change, so we have to take care of that. And so on. Stop when there aren't enough measurements left to consider the new 3 measurement sum. In the above example, so we've got 1, 2, 3, 4, 5 increases here. How many sums are larger than the previous sum? Okay. Copy day 1.c to day 1b.c. I don't want to lose anything that I did before. Okay. So we've got the same file IO here. That all is the same, but the number of increases, the criteria there changes. Suggestions? Well, I need a sum, right? Is equal to array sub I plus array sub I plus 1 plus array sub I plus 2. There's my sum of those 3. Then I'll have the next 3, the next 3, the next 3. Here's an inconsequential speed up slash efficiency. If I've got 1, 2, 3, and then my next 3 are these 3, I don't have to make a sum of 3 anymore, do I? I can subtract this one and then add this one, right? Move that over, subtract, add, right? I'm not going to get that fancy. It's only 2,000 of them. Who cares? Right? So there's my sum. But guess what? I do need the previous sum. Okay. So I'm going to need int sum, current and previous. Okay. So current will be my current sum, and I'll have previous here. What happens for the first 3? Not applicable, so we ignore it. All right, fine. So let's go ahead and initialize previous to something very large so that it will not cause an increase. I know that 2.147 billion is probably big enough to avoid any increase. You see what I did there, right? Here's the previous. It's so large that this will never represent an increase, whatever we do up down here. Okay. So I've got my current is equal to this. And if the previous is strictly less than the current, then I'll increase the number of increases. Right. Now I don't just stop short 1. What should I stop short as? The last 3 here, I want to make sure that I am stopping short so that I'm not going past this once, twice. So minus 2. Okay. I think we're close, but now what? I only ever compute the current, right? How do I set myself up for the next iteration? Yep, previous is equal to current, and then update the current. And of course, I can't have 2 current variables here. Say what? So previous gets the current value, and then I overwrite the current value. All right. Let's see if this at least compiles. Day 1B. 1790. Okay. Maybe. How could I test it? Go back to, oh, here, I can just go redo that. Change this to 10. GCC it. And I think it said it was 5. Oh, darn it. We're just off by 1, so could we get away with, it was 5, right? Where's the, here, down here, 5. Well, if previous is strictly less than current, why would it count the first one twice, though? It doesn't count the first one at all. Here's a sanity check here. We could go with printf. Current is equal to %d and the line current. And let's see if at least we get the same values that they got. 607, 618, 607, 618, 618, 17, all the way down to 792. Yeah. So where is it counting? 1, not, 2, 3, 4, 5. I'm convinced that it's 5. All right, fine. Where am I getting 5? Maybe we're not stopping short enough. Yeah, we could, poor man's debugging, right? So previous current equals %d, and I am increasing it, so I don't need to do anything more than that. Previous current, fine. We got plenty of time, right? If you don't care about this, then there we go. Oh, well, that's because I corrected for it down here. But let's see. Does it correspond to all the ones that we did before? 0, oh, 0? Wait, I thought I set previous to be this thing. Maybe it's too much. 1, 2, 3. If previous, oh, you know what? That's because I did it up here. Of course it's going to get 0 because it starts out at 0. All right? So what we should do is make this into the big one, so that in this line, it'll take that 2.147 billion and put it over here. And now I don't have to correct for it down here. And this is the bad thing about poor man's debugging. You have to go back and get rid of all your print statements. There we go. I'm convinced that that's correct. Undo. Go back to 2000. There we go. Everybody saw what the problem was, right? That I did it correctly, that the previous would be a large number so that it would not induce an increase. But then immediately that was overwritten by current, which was 0. Yeah?
How is current given this value of 0 when we didn't even...
That's a good question. It's all platform dependent. Apparently on Ubuntu, with that particular compiler, it did give it successfully a default of 0. That's not in the C standard. Take this to CSE, and you would get completely different results.
Like an error?
It'd be garbage results, dead beef, some random value, right? It's best practice to always initialize variables anyway. Run this. 1789. Hey, I got 2 gold stars. Return to my advent calendar. Yay. So how many people have started theirs? No? All right. Well, if you're willing to stay up till midnight, you can try to be one of the elites. Is there a leader? Yeah, here's the leaderboard. Joffrey. This means that they contribute money or they're patrons. I don't know if it's Patreon or whatever, but they contribute money and support it. Say what?
The 1261.
I don't know. It's they award points based on the first through the 50th person for each day, and then your points accumulate, etc. I've made the leaderboard on one day in 1 year, but that's all I've ever done. I was like down there anyway, like 50th or something like that anyway. So, yep. All right. We could at least read the next day. Might not be able to do it, but you need to figure out how to pilot this thing. You're on a submarine or something, I think you are. It seems like the submarine can take a series of commands like forward 1, down 2, up 1. So you're probably going to be traveling on a grid. These are the same every single year. It's just a little slightly different. The first one's always just a list of number crunching. Then it gets into grid, turning on lights in a grid, or in this one, you're moving through a grid. So you forward X, you're on an X, Y axis here. You probably start out at the origin, and then you go forward 5, down 5. This is what I'm reading now. Forward 8, up 3, down 8, forward 2. Your horizontal position and depth both start at 0, so you're starting at the origin essentially. And what does it want you? The steps above would modify them as follows. So you'd go to forward 5 adds 5 to your horizontal position, a total of 5, blah, blah, blah. After following these instructions, you'll be a horizontal position of 15 and a depth of 10. So you'd be 15, 10. Multiplying these together produces 150. All of the inputs are, the answers are just going to be some single number here. Calculate the horizontal position and depth that you would have after following the planned course. What do you get if you multiply your final horizontal position after your final depth? So of course you'd have to have some sort of, thousands of instructions like this. Up, down, forward. There's no backwards. Oh. Back. Nope. All right, so you're only ever going up, forward, and down. So you're doing some sort of, squiggly, but only in one direction, it looks like. All right. So, outline. How would you end up going about this in C? Read line by line. Do you have a split function in C? Nope. If you watched yesterday's video, I do go through a split function, like an implementation of a split function in C. If you want to use that code, great, go ahead. But otherwise, you probably maybe already did something like that for Hack 15, right? A CSV splitter of some sort. strtoc, you're right. What I showed yesterday was an implementation of a whole function that took a string and returned an array of strings that did all of that heavy work for you. I would split it forward and then read this in and do a string comparison. If it's up, down, or forward, and then I would convert this to an integer. I would have x and y, and then I would, of course, make the appropriate value that it goes up, positive, or that would be y plus. If it goes down, y minus. If it goes right or forward, then it goes x plus. And then, yeah, I'm going to save that for Monday, or save that for tomorrow, and I'll do that in the main section. I'm not going to get any credit for this anyway, other than my stars. So if you want to watch tomorrow's lecture, you're more than welcome to do that too, and you can follow along with me. If you go into the CSE or CSAB Discord, I think Hunter, he's a grad student, former student of mine, and it was in the LA program, helped build the LA program. I think he is doing an advent of code, so if you wanted to code along with him, you could. I don't know what language he's doing it in, but these are fun because it gives you an opportunity to solve these nice, cute, easy, some hard problems, but it also allows you to, I want to learn Haskell. How would I do this stuff in Haskell? I already know how to I've solved the problem already. How do I implement this in a brand new language that I have no idea about how to use? JavaScript, C#, right? Doing these over and over again in different languages allows you an opportunity to pick up these other languages. No questions online. So what do you want to do on Thursday? can go back even further and get another final, or we can do more advent of code. We'll have plenty of opportunities to do that.
Do another final.
Say what?
Can we do another final?
Yeah, I can bring. There was I can bring final from 2 years ago. I can go back even further if we want. Okay, then I'll see you on Thursday. Otherwise, feel free to join us on Wednesday.